These questions are about run length encoding. So run length encoding is another way of compressing data. So if we remember run length encoding, if we've got 8 symbols like a 1 here, we can replace that with 8 and one of the 1s, and then we've got 4 zeros, replace it with 4 and 1 copy of the 0. We can do the same thing if we've got it in a picture and it's pixels. So if we've got pixels and we've got some of them that are black pixels and some that are white, in this case we'd have 2 white, 3 black, 2 white. So that's run length encoding. So the question we've got is state the feature of data that allows it to be compressed effectively. So the best thing we can say here is lots of runs of repeating values, perhaps. So lots of runs of repeating values, or lots of runs of the same data, something like that will do. So remember, it's called a run length encoding. So when we've got things all the same symbol in one after another, it's called a run. So that's why it's called run length encoding. So this is almost the same question. It's the same first bit, and then it says describe how RLE works. So it's a little bit more tricky. This one, we've got to actually say what we have to do. So there are 2 marks for this. We could say something like the number of consecutive characters that are the same are counted. Don't seem to be able to write very well this evening. So the number of consecutive characters that are the same are counted and replaced with 1 copy of the character plus a number to show how many of the character are in a run. So that's plenty to say there. That works. It says I've got to use an example though, so I haven't used an example. I've used all my space, but that doesn't matter. So if I could use an example, so if I said that something like the string x, 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 y, y, y would be coded as 5x 3y, and that would be fine. And you could do the same thing with pixels or with binary numbers, 1s and 0s. It doesn't really matter what you do for the example, as long as it's correct, of course, and you've got the right numbers next to each other. Okay, so there's another one about in this case sound files. It doesn't matter what it is really, but sound files are stored as bit patterns. They're often compressed the following bit pattern using run length encoding. So we need to recognize we've got 6 noughts and then 7 ones, and I think there's 12 zeros there, and 1, 2, 3, 4, 5, 6, 7. So 7 ones then after that, and that's all we have to do. We just have to write down something like this. So we've got the pattern. You can split them up any way you like. You can do this if you want to make sure that the examiner knows exactly what you're doing. That we've got 6 of 0 and 7 of 1, etc., and you'll get the marks for that. These should be, you know, a nice straightforward 4 points for that, because you get a mark for each one of these, which is nice. Because all you've got to do is count the consecutive number of zeros or ones and write down the number. So that's almost a bonus mark, I think. So then we've got this question, which is a shade the lozenge question. So, you know, for people who are not sure what a lozenge is, it's not something that you suck or eat like a fisherman's friend. It's this thing here. This is called a lozenge for some reason. And we need to shade in the middle section of the one that we think is correct. So, which is the true statement about run length encoding? It will always make a file smaller. Well, no method of compression really always makes it smaller, guaranteed. It's most effective on data that appears random. Well, if we've got random data, we're not likely to have many runs of all the same, so it won't be that one. It will not lose any of the original data. Well, that's true because we know it's a lossless way of compression. So I'm going to shade that middle one in there like that. So we know it's lossless compression, so item C. So there's just a few questions of the idea of run length encoding, and we described how to do simple run length encoding and how to talk about it as well.